been recorded. So I'm gonna double back on some of this stuff. But there's also this page with my office hours. And I have to schedule routine weekly office hours. The college makes me do that. So I have this Zoom link that is set up every Wednesday from 10 to 11. So if you ever need to get a hold of me, you can always come into this Tech Connect Zoom. Okay. And on this Tech Connect Zoom, you'll see every Wednesday there's office hours. So tomorrow there's office hours, next Wednesday, and so forth. You can also see that in your calendar. So if you come into, let me find my calendar. Oh yeah, here it is, the calendar. You'll also see that those should be populated on there as well. So updated calendar feed. Okay. Well, anyway, if you have multiple classes, you have to click on the class and you'll see the calendar of what's due. So this is a good way. I know a lot of you like to plan your week and kind of know what's coming, what's going. This is a good way. And you see every week I have my office hours on there. All right. Now, if it's outside of Wednesday at 10 to 11, you can always open up a Zoom meeting by going to this bit.ly or https://bit.ly Miller Zoom. And that will notify me and I'll be able to pop into a meeting and we can chat one-on-one. Okay. And then the other thing here, and I'm going to get to this when we talk about the labs, is the instructions for connecting to our labs and the computer information that you need so you connect to the right computer and you connect to the right server. The last thing you want to do is accidentally go on to Ryan or Gerson's computer and their server and do all the work, and then when you go to submit yours, it's nothing on there. So you want to make sure you're on the right file. Okay, and then I also have set this up. Hey, Ryan. I also have this set up by week. So week 1 all the way through week 16. Now, some of these are not published yet because I'm rewriting some of the PowerPoints and I'm redesigning most of the labs to fit into this online model. Okay, so but you'll see that I'll always put the PowerPoint and then the lab material that we need to get going on that. All right. Any questions on what we've covered so far on Canvas?
No.
Okay. If you do, you can always just shoot it into the chat if you need to, and I'll open the chat. All I have is a good morning from Christian, and I said good morning back so far. But you can always put a question in the chat, and I'll see it in there too. Now, one thing I have to warn you with Zoom, I have 2 monitors, and sometimes things get lost, right? They pop up behind something and I might not know it right away. So like, for example, I need to check the participants, make sure no one else is trying to get in. But normally I'll get a notice on that. All right. So let me share with you another thing, and then we'll kind of get going here a little bit faster. I'm going to share PowerPoint, and I'm going to share the course introduction. Okay, so this is similar to if you've ever taken a class with me in person, this is what I normally start the course with, where we just intro the course. And if you want to kind of follow along in the syllabus, you'll see some of the same information in the syllabus. Okay, so to log on to your computers, now I have this automated. This will happen automatically when you connect, but the username and password is both CNET58. So if you ever get, disconnected and it asks you for a password for some reason, which I don't know how it could, but if it does, just remember 5858, CNET58 for both. Okay, this course is designed to introduce all the standards, installation, configuration, and management of servers. Now, we are in the middle of a cosmic change in where our servers are located, right? 10 years ago, servers, when you said server, it almost always meant an on-premise server. Like, say you worked for, University of Laverne, and you were their server admin, those servers were located somewhere on that campus. Or if you worked at, Party City, their servers were in their corporate office. Nowadays, that is not always true. The location of the servers, there's been a migration to the cloud, right? With AWS and Azure, Microsoft Azure, and Google Cloud, and Rackspace, and all these different cloud providers, that now our server location is not necessarily on premise. It's probably, some of them may be on premise, the rest of them are probably in the cloud, with the majority of them being in the cloud. All right. So just realize that the server admin is still needed. There is still a requirement for somebody in the organization to manage, know the standards, install, configure, and work with the servers. Just the location, instead of walking into the data center on your job site or in your company, you're going to sit at your computer and remote into your servers into a data center located somewhere around the world. Okay, so this is going to include hardware and software components, virtual server configurations, troubleshooting techniques using flowcharts and diagnostic tools, disaster recovery concept, and our emphasis will always begin with the hardware. And this course, although it is not designed to prepare you for the Server Plus, right? We have a course, and many of you took it this winter, that's CNET64, which is designed specifically for the CompTIA Server Plus certification preparation. But this course is going to kind of be the hands-on part to that winter course. All right. Now this course, I've set this up as a synchronous online class, which means we will have regularly scheduled meeting times of Tuesday from 8 to 2:40. Now, generally speaking, the lecture will go from about 8 to 11, and then the labs are scheduled between 11 and 2:40. Okay. Now, there'll be some days where we may kind of intermingle lecture and lab. And we may say, okay, let's lecture on this. And while we're doing this, let's also start doing this process on the server. If there's things that take a little bit of time, we'll, start to bring those in. Because as I'm sure any of you that have ever worked on a server, there's a lot of, well, let's get it going, and then we just twiddle our thumbs and watch it chug along, and then we check back, and then we click another button that says, okay, continue, and then we wait. There's a lot of that. So we'll try to break that up as much as we can. All right. Now, this course and all of your full 16-week courses, the last day to add a course is the 5th of March, which is next week. The last day to drop a course without a W is the 7th of March. And then you have all the way up until the first day of finals week to drop the course with a W. Okay. So the drop deadline is much longer. But this This without a W, that means the course will not appear on your transcript. So if you print out your official transcript or your unofficial and you request an official, and you drop before 7th of March, this course will not appear on there. After that, it will, but it will have a grade of W, which just means you withdrew. All right. Now, my office hours, I already covered that, but the office hours are built into the calendar of this course. So if you go to every Wednesday, you'll see a meeting from 10 to 11. If you need me outside of that time, just go to the bit.ly, and let me see, how can I point? Yeah, where it looks like I'm pointing at my link here, but the bit.ly K Miller Zoom. Now that's all this information that's in this PowerPoint is found on the Canvas site. All right. Now you will have to use Canvas to get to this site. Obviously, you've all done that, and that's at inside.mountsac.edu. And then once there, you can click on Canvas, click on Login to Mount Sac Canvas. I'm going to provide, there are no course materials that you have to purchase for this course. Okay. Everything that we are going to use in this course are included in, I'll provide those. Either I'll put it in the notes or we'll have it available to you with links on the website. Okay, so there's nothing to purchase, which is kind of a nice thing for if you have several classes and each one of them says you have to buy this and you have to get this book and you have to pay for this subscription, and you know, these online classes, someone can be very expensive. So I want to be a little sensitive to that and make sure, you know, you can't, I don't want people not to take this class because they can't afford it. To me, that's not right. Okay, so everything's there. How this class will be assessed, there's going to be 4 quizzes. There's going to be 14 labs. There's a midterm exam, a lab midterm exam, a final exam, a lab final, and then finally your participation, which is basically your attendance, will all add up to 700 points. Okay. Now, the quizzes will be, you can look at the schedule, the weekly modules, and you'll see where those are as we get going. As I said in the introductory email on Saturday, this course is kind of under construction. So just be aware that it's not 100% complete at this time. I'm working on some stuff. So you'll see where those will pop up, and you'll have plenty of time to take those. Okay. All the quizzes and the exams, so the final, the midterm, the lab final, the lab midterm, quiz 1, 2, 3, and 4 are all open book. Okay, so they're designed to teach you, to refer to the course material or to refer to outside sources, whether it's Google or Microsoft or Cisco or, Amazon or wherever you go to, AWS, I was thinking of, you can look up the information, because I like to put this in real world. When I was a IT director, my boss never came to me and said, Ken, I need you to answer this question. I need you to tell me you have 5 minutes to tell me the correct answer. You can't look at any of your diagrams. You can't look at any of your notes. You can't look at any of your reference material. You can't search for it on Google. Tell me the answer, yes or no. What is the correct answer? And if you don't get it right, you're going to fail, your monthly performance review or whatever. I mean, that's not the real world, right? In the real world, IT professionals have to learn to find information. So that's what the model I'm using for the assessments in this class, is you're gonna have to go find the information. All right. But as you can tell, the bulk of this course is all in the labs, right? The hands-on part is the majority of this class. Almost a little under 50% is the labs. So if you if you do the hands-on stuff, you're well on your way. All right. There are 14 lab assignments. Each lab is worth 20 points. You have to be present when we meet to do the labs, right? Some of these labs are very, I don't want to say they're tricky because they're not designed to be tricky, but they can be difficult for me to say, click on this without telling you, because I want you to learn, right? Like if I say, modify your DHCP scope, in 3 weeks or 4 weeks, when we start doing that kind of stuff, you should know where, at least how to find that in Server 2019. Okay. So if I just have a picture that has, if I give you step-by-step instructions all the time, like how many of you still ride a bicycle? Anybody?
Yeah.
Okay. Do you still have training wheels on it?
No.
Okay. You took those off, right? At some point, once you kind of learn get your balance and learn a little bit about how to bicycle, how to ride a bicycle, you're not going to have training wheels. So in this course, now this is normally, and I know things aren't normal right now at all, but normally this is one of the last classes most students will take in the CNET program. So at this point in your career, career at Mount SAC anyway, as a student, the training wheels need to come off at some point. So, some of the labs in the beginning classes have a picture and a circle, a red arrow that says click here, type this, press enter, right? They kind of walk you through the process. In this class, in the beginning, I'm going to do a little bit of that, but then it's like, my dad, here's how he taught me and my brother how to ride a bike. He said, let's push our bikes over to this big hill. And he said, okay, boys, get on. And he took out his crescent wrench. He took off our training wheels, and I have a twin brother. He had one on one side, one on the other. He said, okay, I'm going to just gently push you over the top of this hill. And gravity took over, and you just start going, and you get that sense of, hey, I'm balancing, I'm going, you start pedaling, and that was it, right? So I'm gonna do something similar with you, where in the beginning I'll have the training wheels and I'll hold you and I'll say, come on, you can do it. But at a certain point, I'm gonna just push you down the hill and away you go. All right. So you're gonna have plenty of time to do these labs. So don't stress out about time. I mean, if you do things orderly, you'll have more than enough time to do them. And you want to make sure you do the steps in order. If one of the things we need to do, in some of these labs are going to get, I don't want to, not complicated, but there's going to be a lot of moving parts. So for example, if we have an email server running and the email user accounts are authenticated against our domain controller, and your domain controller isn't on, right? The virtual machine isn't turned on, which step one would probably be, configure your domain controller, blah, 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 make sure it's running. Step 9 will be on your email server, connect your email accounts to the DC, the domain controller. And then if a student says, hey, I'm getting an error, I can't connect to my domain controller or my email accounts, well, go back to step 1 and make sure your domain controller is running. Because a lot of times, it's something simple like that there's no connectivity that you have to look at. So make sure you kind of take a big picture view of some of these labs and say, what exactly are we doing here? How is this server communicating with this other server? And what information is shared between them? And then once you kind of get a feel for that, it'll help you get through these labs, and you'll go, that's why step 1 was this. Yeah. All right. Here's some basic stuff, answer incomplete sentences. I'm going to do a lot of screenshots in this course. So when you submit your work, it'll be a Word document with a screenshot in there, and I'll demo and explain that later on when we talk about the lab or when we do the lab. And then finally, if you have the opportunity to install a toolbar, resist it. Just fight that urge. I know we can't help our mouse from hitting click, continue. Just trust me and resist that urge, and don't click on any toolbars. All right. So the midterm exam, the lab midterm will be on week 8. So, which is April 13th. And on that day, that's all we're going to do. You're going to have a couple hours to take the midterm, and then you have a couple hours to take the lab midterm. And when you're done, you'll just say, you'll submit it, say, here's my lab midterm. Then I'll go in, I'll remote into your machine, and I'll double check and make sure everything's right. And I'll unwrap that as we get closer. The final exam and the lab final exam will begin on June 8th. Now, there's a natural break in this course, right? We have a midterm and for the first half, lab, the final for the second half. So what I've decided to do is the first half of this class, we're going to work exclusively with VMware's ESXi hypervisor. That's going to be our platform of choice for the first 8 weeks. And then the lab midterm will be on ESXi. After the midterm, we'll go through and we'll reconfigure all the servers and set them up with Hyper-V, and then we'll use Hyper-V the rest of the term. So the final will be done on Hyper-V, okay? So Kirsten got out and back in. So those exams plan on being available on April 13th and June 8th. If you're not, your scores are going to be adversely affected, right? You've got to be here for that. Now, something comes up, if you know in advance, we can make some modifications. But notify me prior to the exam. Don't come to me on April 14th and say, oh, hey, Professor Miller, I had a personal problem. I couldn't use my computer at all yesterday. Well, that's something you should have told me before April 13th, not after. Okay, so keep that in mind. Okay, attendance, I'm going to take attendance by just looking at the participant list. I'll see that in the transcript of the course. I can get the information. Then I just have what I'll do is at the end of the course, if you were at all of the meetings, you'll get all of the 20 points. If you're at some of the meetings, you'll get some of the 20 points. All right. And also, if you decide to drop this course, right, at some point you just say, yeah, that's not for me, or my schedule changed, I can't come anymore on Tuesdays, or whatever the situation may be, make sure you go in to the portal and drop the course, right? You're able to add it. I'm assuming you're able to drop it. All right. Academic honesty. Now, again, in the labs and, when we're doing any kind of group work, it is perfectly okay to ask questions. In fact, I would encourage you to ask questions. So even today, even though we're virtual, if you have a question about something in the lab and somebody else is having the same problem, just unmute yourself and say, hey, does anybody know where this is? It said to get the CPU information for the VMware server. Where is that? Now, granted, I'll be sitting at my computer during the labs too. So I would naturally be the one to answer most of those questions, but feel free to help each other, right? This is a learning environment where my goal is not just to drill this information into you. Well, that is one of my goals, but the primary goal is to teach you how to learn and to become, a critical thinker and process information. So And sometimes I know the best way to do that is to ask of somebody else, because they may say, yeah, even though the wording in the lab says this is what I interpret that to mean, and this is how I did it. Okay, because it's hard sometimes, you know. That's what I should do. I should have each one of you write and do the lab, come up with the lab. I'll give you the outline, and you word it, because sometimes it's hard to say, like, how do you explain? Click on the start button and um, type in the search area. I mean, some of that's easy, but what if it's not exactly that like that? Like in CentOS, there may be a picture of what I consider to be a disk, right? Maybe a CD or an optical disc. And I'll say, click on the picture of the disc, and someone will go, I don't know what you're talking about. I don't see a picture of a disc. And so sometimes it's difficult. So be encouraged to communicate. Now, the tests, the quiz, the midterm, and the final are individual. Those are not open for group discussion, right? You're not going to say, hey, Robert, what'd you get for number one? Cool. Frankie, what'd you get for number two? Alan, what'd you get? Troy, that's not the purpose of when I say it's okay to work. However, the exams are open book, open note. So that takes away some of the pressure there. But don't collaborate on the exams. Every other place you can. All right. Now, there's no reason to download or otherwise copy anything because I'm giving you all the course material. And then finally, just some, Zoom etiquette stuff, mute yourself, turn off if you have anything in the background. We've all seen the embarrassing Zoom videos, a kid's on Zoom and then the dad walks by in his towel and in the background, because the camera's facing that way. Or, what was the one the other day? The guy's on Zoom and the wife just decided, I'm going to come and just give you a kiss on the head. And he's like ducking and bobbing, and it's all on Zoom, everybody's seeing it. So just be careful, with what you have on Zoom. Um, uh, just be safe is what I'm saying. All right. Playing games, texting, whatever on your phone or on your computer during the lecture is rude and will not be tolerated. But I'm going to tell you right now, I cannot see your screens. Okay. So if you're multitasking, there's no way I'll know that, other than when we get to the lab and you say, what are we doing? And I've taken half an hour or 45 minutes to explain it. Then I'll know you probably weren't paying attention. So pay attention. And then finally, if you get tired, stand up. You're in your own house or you're at work or wherever you're at. Do a couple stretching exercises, do a push-up or two, and then get yourself ready to go again. All right. So let me stop this share. And now, are there any questions or comments on what to expect from this class? This is your turn. Yeah, go
Maybe
ahead.
not to what to expect, but I have a question for say if we have like a problem that we can't describe, it's kind of hard to describe. Are we able to share our screen?
Absolutely. Good
Okay.
question, Frankie. Yeah. In fact, I'll ask you a lot of times, show me what you're talking about, because that's a lot of times that's the fastest way to get to the solution. And I'll say, share your screen, and then I'll request remote control so I can move the mouse and we can see together what's going on. And what's nice is if other students have similar, they can watch how we do it. And I want the labs to be that way. So if you're doing something and there is a problem or a area that's not 100% clear, we'll work through that together, because that's how we'll get better at this. All right, good question. Anything else? No, normally you can tell when someone has a question because they'll unmute themselves. And I don't see anybody unmuted.
So for the second part of the course where we're using Hyper-V and CentOS, so we're going to be learning how to do servers with Linux, correct?
Well, one of our servers, so we're going to use, I don't know if any of you've ever seen at at the college at Mount Sac in the stock room, we have 2 big data racks full of servers. So those are the servers that we purchased for this course. And for the first half of the course, those servers are configured. I went in last week, and normally this is where, you know, things get, I have to change things up a little bit from the way I've done it in the past. Normally our first lab is I wheel in the servers, you take them out of the rack, you open them up, you look at them, and then you install VMware ESXi's hypervisor on them. Well, we can't do that, right? I couldn't say, well, meet me at the stock room, pick up your server, take it home, install it, bring it back. I mean, that would be a logistical nightmare. So I went in last week and I configured all 24 servers in the rack with ESXi. So that's what we're going to use. Now within the hypervisor, we will create basically 3 different operating systems. We're going to do Windows 10 for our client testing, Server 2019 for our Windows Server activity, and then CentOS, which we're going to use the latest version, really the last version, right? I don't know if you saw, but Red Hat pulled the plug on the CentOS project and they're moving to a different thing. And they're phasing it out, but the CentOS and Red Hat are almost code for code identical. But CentOS 8 will be another server. So next week, if you look at week 2 at the PowerPoint, it says design our environment. That's where we're going to talk specifically about all the servers we're going to build for this course. So for example, we're going to need servers as routers. So we'll set up a Windows server as a router. We'll send up a CentOS server as a router. We're going to talk about websites. So we're going to build a website on a Windows server, and we're going to build a website on the CentOS server. We need email servers. So we're going to do an email server on CentOS. We're going to do an email server on Windows. We need DHCP. We need DNS. We need file shares. We need Active Directory. We need remote access. We need all VPN. We need all this stuff, honeypots and firewalls and all the various things that we need. So we'll use different operating systems on our machine. Now, after the midterm, those servers that are running ESXi now will be reconfigured. I'll reinstall Hyper-V with Windows Server on them. And then that will be our kind of our base hardware for that. Okay, does that make sense, Louis?
Yes, thank you.
Okay, good. Any other questions or comments? All right. Well, this is the part. Now, the other thing, just logistically, during this course, right, while we're meeting together, I'm going to try to take a short break at the top of each hour. So right around 9 o'clock, we're going to stop. And I want you to literally get up from your computer, right? The last thing you need to do is sit at your computer for an hour at a time or 6 hours for this course. Get up, go get a cup of coffee, go take a biology break. I was in a Zoom meeting. That's what someone said, I need a biology break. I was like, what are they talking about? And they're like, oh, I get it. I'm not a biology major, but I figured that one out. And, just step away for a second, just flex your back and stretch and do whatever you got to do to keep your sanity. So every hour I'll try to take a break. Now during lunchtime, so from 11 till 12 or 11:30 to 12, if you want to, you can take a lunch. I don't mind, in the lab, I always say, don't eat at the computers, right? Because no one wants your Cheeto fingers all over the monitor and the screen and the keyboard at school. One, because if you had a light, you would be, a black light, you'd be like, oh my gosh, what's on these computers? But a lot more than just COVID, right? But at your computer, I mean, if you're comfortable eating at your computer, I don't care if during the lab, if you grab your lunch or snack or whatever and do that. I haven't figured out how to schedule. I don't have a button in Canvas yet that says DoorDash to all your houses. Maybe that would be a really good program if somebody wants to make it. It'd probably be $1 million idea to add that, where for all this online instruction, the instructor could DoorDash and then have a poll where people could say, I want Subway, I want Taco Bell, I want whatever, and then just press a button and it goes out and it just comes right out of your student fees. That would be pretty cool. But I don't have a way to do that, so we're on our own for lunch. So I just wanted to tell you that. Okay, so I'm going to share another screen here, and for some of you, this is going to be the most exciting thing that you've ever seen, and others of you, you're going to go, I've seen this before. It's pretty awesome. And of course, I'm talking about Kahoot. So I'm going to start Kahoot, and we'll do this. And can you guys see that screen?
Yeah.
All right. So it's got a really good soundtrack. So you want to make sure you turn on your speakers. So if you go to kahoot.it, or if you have the app on your phone, go to the Kahoot app, put in the pin as 702226 and join. Now Ryan's in. Make sure that I always tell my class, no naughty nicknames. So, don't say anything off color. That would make us embarrassed. So your names are fine, I guess. That's pretty clean. Frank the Bank. Are you related? Are you Frank the Tank's kid? From,
No.
old school? Baby Yoda. Love it. All right, so we'll give everybody a chance to get in here. Now, I don't know if the music is going to go through my machine to yours or on your machine, but probably just from mine. All right, so we'll give everybody a chance to get in here. And I like to use this Kahoot as kind of like an assessment test, although this is not graded, just to kind of see where you're at, right? Sometimes you may go, yeah, I've got a really good idea that I know just about everything about servers. And then we talk about something in this Kahoot and you're like, oh, I thought I understood that, but I guess I don't. Well, that's good. This is not intended to demean your understanding of anything. It's just to show this is what you're going to know inside and out by the time we're done with this class. All right. So I don't know if that's everybody. $15, $16, we have 19 people. So maybe somebody's on their biology break early here, but anyway, they can jump in later. So I'm gonna get started. And the way this is gonna work is you'll see a question on the screen, and then you'll see 4 different colors and symbols with the answer. And you're graded, or you're awarded points based on how fast you can answer the question and how correct you can answer the question. So there's 2 things. You got to know it, and you got to know it quickly. And then at the end, we'll get our gold medal, our silver medal, and our bronze medal. Okay, I think everybody's in there. So let's start this baby. Here we go. So what's the default port number for HTTPS? 2280, 123, or 443? You only have 5 seconds to answer. And 7 of you got it right, and it's port 443. Now, when we do our web server and our web development lecture and lab, you'll need to know that, because you need to punch a hole in the firewall that says allow traffic in and out of port 443. That way we can use the HTTPS service. Okay, so JP, he was not only correct, but he was very fast. Alan was correct, but not as fast. Jose, Frank the Bank, and Robert. Okay, next question. Use the what to create virtual machines, configure settings, and manage VMs? The guest console, the user console, the administrative console, or the deployment console? What console do you think you use to manage VMs? Pretty obviously, obvious that one should be the administrative console. Okay, so when we say in ESXi, create a new VM, and you're looking at the data store, you're not in the right spot, right? You've got to be where would I do that? And that's probably in the administrative console. Okay, let's see here. JP, still in first. Isaiah's came up. Look at that arrow. You're moving up, young man. Good job. All right, quiz. Question 3. You can use a what kind of disk to create a virtual machine that links to an existing parent? Differencing, subsystem, cloned, or mirrored? And the correct answer there is a differencing disk. Now, when we start installing these, and how many of you took, some of you took CNET58 with me in person not this last fall, but the year before, right? Before the pandemic. And remember in that class, the first lab, what do we do? Well, we installed Windows, we installed CentOS, we installed, right? There's like 3 or 4 installs, and it's the most exciting thing an IT person can do is install operating systems. I say that with full sarcasm. So the best way for us to prevent every lab, because we're going to build at least 25 different machines in this course. And the last thing I want you to do is sit there and twiddle your thumbs for 25 hours while this machines are installing. So we're going to speed that up by using the relationship between a parent and child disk. And in Hyper-V, it's known as a differencing disk. In VMware, it has a different name, but so that's how we're going to speed things up so we don't do that all the time. All right, let's see here. JP still in first, although nobody got that one right, so that's kind of a holdover. Next question. Question 4. In Hyper-V, you can add blank virtual network adapters when creating a virtual machine. How many? 1, 2, 3, or 4? So let's guess, and the correct answer is you can add 1 virtual network adapter when you create the VM. Once it's created, you can go in and add up to, I think it's 6 total network adapters for a virtual. That's a lot of networking for a virtual machine. So the correct is when you install or create the VM, you can only do a single network card for that time. And we'll go through this. You'll see this. We're going to build our first VMs next week. This week, we're just kind of getting used to the environment. So let's see here. Oh, Jose, commanding lead. Look at that arrow, moved way up. That should be a big arrow. All right, question 5. By default, when the host machine shuts down, the virtual machine is put into a lock state, standby state, stack state, or save state. And the correct answer is save state. So it just kind of hits the pause button. And then when the host machine, the host server starts back up, the VMs will come back online. So if it powers down, those servers our virtual machines are saved, so we don't have to go back in and you know, start them up again. All right. And Jared and Isaiah and moving up.
Yep.
So let's go. You got 4 questions to win this thing. The accumulation of many specialized servers creates what is called server bloat, server sprawl, server chaos, or server panic. And that's server sprawl. And this is one of the things that can happen with virtualization is it's just so easy to have servers all over the place that we end up, you know, well, let's do a server for our web server. Let's create a new server for file share. Let's create another server for a new DNS server. Let's create another server. And before you know it, you got 500 virtual machines, which is known as server sprawl, because they some of these, you know, servers say DNS does not play well with Microsoft Exchange. So you don't want to put those on the same machine, right? And you start doing that several times and you end up with, you know, 15, 20 different servers doing 15 or 20 specialized things. Let's see here. Oh, JP said, I'm coming back. The comeback kid. Here we go. Question 7. A Hyper-V physical disk file has what type of extension? VM disk, VMD, VHD, or DSK? So this is in Windows, and the Windows default disk naming convention with the extension is VHD. So with VMware ESXi, it is the VM DSK, not DISK, but DSK. And it's important we know what those disk files are, because that's like a file that actually contains the hard drive of the machine. And we know with computers, if I take the hard drive out of my computer and put it in another computer and turn it on, that computer is now on that, or that information is now on that other machine. So when we move these things around, knowing what file we're working with, kind of a good idea. All right, let's see here. Okay. Oh, I'm not going to say you have a commanding lead, John Paul, but you're getting close. All right. Question 8. How many VMs are licensed to Server 2012 standard? 1, 2, 50, or unlimited? So standard, you only get 2 licenses. If it was the Server 2012 data center, then you get an unlimited number of licenses. And we're going to talk about licensing in virtualization, because just like server sprawl and server bloat is where you end up with way too much stuff. Sometimes it's easy to just pop this up, pop this up, pop this up, pop that up. And before you know it, you have 12 servers and you only have 2 licenses and you're out of compliance. So as a server manager, you have to make sure licensing is in compliance as well. Let's see here. Oh, Al Michael and Troy moving up. You still got a shot at 3rd place here. I don't think you can get to the top. Question 9. VMware Workstation example, what type of hypervisor? Type 1, type 2, type 3, or type 4? And that's a type 2. So type 1 means that the hypervisor runs directly on bare metal, so right on the server hardware. Type 2 means an operating system runs on the bare metal, and then the hypervisor runs on top of the operating system. And VMware Workstation does just that. And in a couple of weeks, we will take a short look at VMware Workstation. So we'll actually install VMware Workstation and create a VM and then migrate it from Workstation back over to ESXi. And as you could probably guess, VMware has developed their system so that Workstation and server work very well together. Just like Windows, Windows 10 works pretty good with Microsoft Server and Hyper-V. Let's see here. Oh, what happened there? I skipped it. All right, number 10, question 10, fault tolerance, backups and disaster recovery all refer to the same thing, true or false? And hold on. So here's the podium. Here's third place is Troy. So you did move up, Troy. Good job. Second place is Jose. And then our first place winner in the spotlight is John Paul. Look at the confetti. Hopefully that fell in your house, right? So that's just a short look at some of the assessment information. So that's stuff that we're going to now. If you went through there and you're like, I've never heard of any of that stuff, that's okay, because in 15 weeks from today, when you take the final exam, you will be in a position where you can say, now I've done all that. I know exactly what, a differencing disk is. I know exactly what port 443 does. I know exactly, about failover, fault tolerance. I know everything that we talked about, the DHCP scopes and, servers that are used here and there. So that's not designed to make you feel like you don't know what you're talking about, but it's definitely designed to make you think, this is what I'll learn over the next 16 weeks. All right. Any questions or comments on anything? No? So it's 9 o'clock. Let's take a short break. Let's come back at 9:05. So about 4 minutes from now. Yeah, there you go. Use code MONTSAC for free delivery. Perfect. But let's go warm up your coffee or go, walk around the block. I don't know how big your block is. You might not be back in time, but and then let's start up again at 9:05. All right. So I will see you then. I'm gonna put on a virtual background. So I've gone golfing. I'm at the golf course. I'll be back in 5 minutes. No, I'm good. No, I'm good now. Okay. I did too. All right, so welcome back. Hopefully got everything taken care of you need to take care of. Now, what I'm going to do now for the next probably couple hours is we're going to just do the week one PowerPoint. So I'm just going to walk through. I'm not going to cover every slide. They're there for you to take a look at. And just kind of hit some of the highlights. So if you go to Canvas, you can open this file if you want to open it on your own. You can download it. You can put it on your machine, whatever you want to do, or you can just follow with me when I share it. A quick jog, good. How far did you go, Jared? 2 miles? You run a 2-minute mile? Just kidding. All right, so let me get outside my door. Perfect. So this is just the PowerPoint that is on Canvas. So this is just the first lecture here. So let this get all caught up. Let Abraham back in. And here we go. All right. So what is virtualization? And one of the key things that we need to understand, I mean, it's kind of like when I tell students, we're going to talk about the cloud, a lot of CNET students are like, yeah, I know what the cloud is. It's where you share or it's where you store files. Well, the cloud is way more than just file storage. There's all kinds of elements to the cloud, right? The platform as a service, the infrastructure as a service, the software as a service. So the same thing with virtualization is a lot of times we think of, we can virtualize our operating systems, which is very, very true, but we can also virtualize applications. We can virtualize our networks, our storage, and of course, our client workstations and servers. So when we talk about that, just expand your understanding of what is virtualization to include all of those other things too, other than just operating systems, okay? And virtualization is a relatively new technology. And I say relatively in technology terms, it's been around for some time now, probably, 15 years when it first started, which, in regular time frames, that's not that long. But in technology, it's been around for some time. And it really allows us to use the same hardware to envelop or capture different operating systems and allocate the hardware accordingly. Okay, so we're gonna look at how the virtual hypervisor, which is really the heart or the brain behind the virtualization, how it does that, and we'll develop some terms here along the way. So the server or the host machine, another name for that is the hypervisor. Now, in VMware, the name of the hypervisor is ESXi. That's the name that VMware gave their hypervisor. In Windows, in Server 2012, 16, 19, 2008, whatever version of server you're running, it's called Hyper-V. And I always give Microsoft a hard time for their awesome naming convention, right? Well, someone at Microsoft must have won a contest, said, come up with the most creative name for a hypervisor. And someone said, how about Hyper-V? Oh, you win, Or what should we call our new technology server? How about NT server? I mean, they're really good at naming stuff. Sarcasm again. Okay, so and this allows all of this to run on the same hardware where we can have multiple independent virtual instances. And where this really comes into play for this course is if I were to ask you to design a web server and I wanted to have a MySQL database on the back end, and I wanted to have to communicate using PHP. So you have a PHP language on there. And I wanted to run on Linux. And you said, well, where I need 4 servers. I need one server for the website, another one for the SQL server, another one for the PHP server, another one to manage all of it. Where I need 4 servers to do one lab. Well, that's going to be kind of hard to do in a school, let alone in a business. So virtualization allows us to do multiple projects, and in a lab environment, a learning environment, to establish multiple copies of similar hardware in a virtual. So instead of saying, let me set up a server, it's like, let me install a virtual machine inside of my server. So it gives us the flexibility to do that. Now, although virtual machines use the same physical resources, right? If we go into a virtual and look at the device manager, you'll see that device manager is still going to say there's a processor, there's memory, there's a video card, there's a network card, there's your input output, there's your USB, there's all these different components, network, all those things, as if it's on an actual physical machine. So it's virtualized. And the way that does that is it uses what's known as the Trusted Computing Base, or the TCB. And that's a concept that allows the virtual machine to only see the data that is required by the virtual hardware of the virtual machine. So your virtual machine cannot, I mean, it's physically and conceptually impossible for your virtual machine to see the data flowing through other virtual machines or the host machine, which is super important for security reasons, right? Because we would not want a virtual to be able to sniff or read all of the information passing through the main CPU for the server, the host machine, okay? So the Trusted Computing Base is a set of all hardware, firmware, and or software components that are critical for its security, all right? Now, when a virtual machine is provisioned, we have to, when we set it up, and we'll do this next week, when we set it up, we have to give it a certain amount of memory, a certain amount of hard drive space, a network connection, and a slice or two of the processor. And while it's running, we cannot change that, right? Just like on your computer, if I said, hey, add another stick of memory to your computer while it's running, you'd probably have to go buy a new motherboard and buy some new memory. And I mean, you don't do it that way, right? While it's running, you have to shut it down and make sure that you don't have that issue there. Okay, looks like a student joined my office hours, not the class. So I'm gonna, okay, I don't know how I'm gonna fix that, but so these things some of them can be shared. Like, for example, when we look at our ESXi server, there is 32 gigs of RAM, or of random access memory on the server. And we are going to share some of that memory. Now, the key here is we cannot share more than what we have, right? We cannot say, I'm going to give this machine 16 gigs and this other machine 16 gigs and a third machine 16 gigs and turn them all on because I don't have 48 gigs of memory. I only have 32. So we have to be able to manage that and make sure that they're that, because they cannot share the memory. Once that virtual machine starts up, it claims or stakes out the use of that memory. So no one else can get it, right? It's like, this is my memory. I'm not sharing with anybody while I'm running. Okay. Other resources can be shared and used at the same time, like the hard drive can use it. Now, it can't use the exact same sector and the same location on the disk itself, but it can share the hard drive as a whole. And the network is shared all the time too. Okay. So why would we virtualize? Well, traditionally, and there was a study done a while back that showed that most servers are underutilized. You know, they may be utilizing 40% of the system resources, the CPU and memory and hard drive and network. And imagine if you were the owner of a company and your IT team came to you and said, hey, boss, we need to buy 3 brand new servers. Each one of them costs around $12,000 a piece. And we need it for, this project we're going to do. And the boss says, okay, here, I approve that request, go through purchasing, and away you go. And let's say 6 months later, the boss walks through the data center and says, hey, show me those servers we spent, 12,000 a piece on. Show me what they're doing. And here's one server, and you go into the system and it shows it's being used 10%. And you go to the other server and it's used 12%. You go to the other server, it's used 5%. And the first thing the CEO is probably going to say is, why did we need 3 servers when we're not even using half of one of them, right? It's like, have you ever drove by where the California DM, the construction on a project, right? And there's one guy holding the sign and 3 guys are watching him. And then there's one guy in the hole and there's 7 guys watching him. And how many of you go, I think they could probably do this job with maybe 2 or 3 guys, not 12. All right. And, that's just bureaucracy and, the 10 freeway, exactly. So the idea here is we want to maximize the return on our investment. So the way we can do that in our servers is with virtualization. Now, the other thing is they take up space, right? And space, although now office space is not a problem, right? Because nobody's in the offices. But in regular times, everybody's clamoring for more office space. And one of the things that kind of runs low is, where do we put all the servers? So because not only do we need the servers to have their own home, they need power, they need cooling, and then of course we need somebody to administer them. And a funny story about Mount SAC, and I've worked at Mount SAC, this is my 10th year. And Mount SAC used to use for the staff email, they used an older email platform that there was one person that knew how to manage it. And when I started at Mount SAC 10 years ago, I said, why are we using this older Domino server mail system? And one of the guys in IT said, well, what would you rather use? I said, why don't we use Exchange or Outlook or do something? that has more functionality. And his exact response to that was, we are planning on doing that as soon as that administrator retires. So that was their job, and that's what they did. And they were the only one that could administer it. And then as soon as they left and that person retired, then they moved to Office 365 and Exchange in the cloud. So, sometimes you run into those type of scenarios. All right. So we can consolidate our servers. We can reduce costs. We can run older applications on new hardware. And this is where we come into play in this course. We can test new technologies without having to buy, $50,000 worth of servers every time we want to run a lab. So in our labs, I can say, create this server and this server and this server and this server. And within 10 minutes, you'll have all those going. And then we can develop the platform that we want on there, and we can test things out. So for a learning environment, for a lab environment, this works out perfectly. So then we can easily do that. We can also convert physical machines to virtual machines, and we can optimize our data center with what's known as virtualization orchestration. So, just think of, Mickey Mouse and what's that movie with Mickey Mouse, Phantasmic or whatever, and he's orchestrating all the different sections of the orchestra. That's what this would do with our data center. Okay, so what else? The other thing it's going to do is increase our uptime. Our disaster recovery is going to be better, right? We can really streamline how we go from disaster to recovery. Very, very easy. And then it allows us greater workload mobility. So imagine if everything let's say all the things in CNET could only be done on a server inside the friendly confines of building 28B, right, where we're housed. Well, for the last year, the last 1, 2, 3, 4, 5 sections of the spring, summer, fall, winter, and then again this spring, we would have no course offerings, right? We couldn't do it. But with virtualization, we're able to work and still do some of these things virtually. So it really has given us that mobility, which is super important. All right. And then, on that note, they're saying a lot of workers, they may never go back to the office, right? Some of the owners of these companies, one, they realize, hey, I don't have to pay rent for a building downtown that's, thousands and thousands of dollars a month for just renting it. And then the electricity and all the things that go along with that, insurance. They're like, these workers are actually getting more done at home than they are, when they're in the office anyway. So that mobility has some benefit too. So we can do a couple different virtualizations. So the types here, we can virtualize our servers, we can virtualize our network, and we can virtualize our storage. So server virtualization is really what we're going to do, right? That's what this course is, right? Servers. So it makes sense that we would spend the majority of our time on that. And this is where we can build virtual computers on a physical computer that is running virtualization software. So for us, that's going to be running ESXi, and then after the midterm, it'll run Hyper-V. And we can take advantage of the powerful server by really maximizing the utilization. Now, there is a point where you just don't have enough horsepower in your original server, your host machine, to run any more virtuals. And at that point, that's when we need to switch gears and either cluster our virtuals with our host machines to take advantage of some of those things. This is going to save power, cooling, and space requirements. Now, one of the largest expenses in a data center, after you buy the servers, you have to cool them. And that cooling leads to power costs as well as the air conditioning in the room, right? Have any of you walked into a data center? And normally a lot of data centers on the outside of the door, they'll have a parka on a little clothes hook. And when the admin goes in, they slip on that jacket because it's normally like, 50, 40 degrees with the air conditioner blasting inside the server room. So, keeping them cool costs a lot of money. Now, Microsoft did something really cool a couple of years, probably about 5 years ago. They said, we're going to put some of our data centers in the ocean. So they put them in these pods, and then they lowered the pods down into the Pacific Ocean off of the coast of Washington, and they let the ocean currents cool them. And then they just pulled them out. I just saw an article a couple of weeks ago where they pulled them out for maintenance to clean out the filters and stuff, and then they're going to lower them back on there. So, now some of you are probably going, well, that's why the ocean's warming up. Blame Microsoft, right? So, have any of you been following? Well, I mean, how can you avoid it? The climate change stuff, but the rise of Bitcoin, right? Bitcoin's really taken off, and they're saying now one of the biggest threats to the environment is Bitcoin mining because they use so much power. Yeah, someone go on Google and search for write the house that has a Bitcoin miner, and they'll show like 5 houses. This house has got a bunch of snow on the roof, This one is completely clean, and that's a Bitcoin mining house. And then, because they give up so much heat, it's pretty crazy. Yeah, Troy, it was 56K. It dropped. It's now like 49 or 42 or somewhere down there. I checked this morning, but that's it. Yeah. So there's that. Now we can virtualize our network, which allows us to have different networks for different things. This is done by splitting the resources bandwidth into channels and allowing the administrator to assign these resources. So those of you that have taken CNET58, right, which I know many of you in the class list, I can see. I remember you were in the server or the networking class. What is the basic definition of a router? Somebody give me what I define a router as.
Yeah, it's like kind of like a device that interconnects networks.
Exactly. It's a device that connects 2 or more separate or different networks together. So like in our home network, our Fios or our Spectrum or whatever, their router, one end connects to them, to Spectrum, the other end connects to our home network. Those are 2 separate networks, and the router interconnects them. Well, if we're going to do networking inside of our virtual environment, we're going to want to have separate networks so that certain things are happening over here for A, for accessibility reasons, or B, for security reasons and management reasons. And then over here, we want other resources to work, and to interconnect them, we'll use some sort of a router. So we'll bring that into our design next week, but the virtualization of our network allows us to do that very simply, okay? Now, we can also do our storage virtualization. And the reason we want to do this is that just like, I mean, if you're in your home office or an office space, or maybe even your room where you have, say, a dresser drawer, do you separate, how many of you take out all the dividers between the drawers, so everything is just one big box. Nobody does that, right? You want a separate drawer for certain types of information, another container for other types of information, and so forth, right? You want your socks in one drawer and your underwear in another drawer and your t-shirts in another drawer, and you separate those so you can organize things. Well, the same thing with our storage. We want those to be compartmentalized so that we can A, label them accordingly, and B, assign permissions appropriately. So we don't want, if we just said, here's everything, and everyone has permissions to it, that's a recipe for major disaster, right? So we want to be able to say, here's our accounting information, here's our IT information, here's our, faculty information, here's our student information, and we don't want those to bleed together or overlap, because then we're going to have some problems. So file-based access to data, no matter where the actual data is stored. So again, this concept of where is my data is almost anecdotal now, right? People with the cloud and the virtual storage of our data, where it is doesn't matter as much as what condition is it? Is it available? Is it secure? Are the permissions correct? Right? Is it being backed up? Is it, optimized in those areas? Those are questions that are more important than where is my data, right? Because like if I were to say, where is, when you upload a file to Canvas, where is it stored? Well, the answer to that is, well, I don't know. I know Canvas is hosted out of Sacramento, right, at the state chancellor's office. But I also know Canvas has data centers throughout the world, right? Very few of them are actually in California, because California is an expensive place to run power and cooling, right? It's one of the more expensive ones. But it could be in the Northwest. It could be in, other parts of the world. But, where is it? I don't know. As long as when you upload today's lab file, it gets into the queue so that Professor Miller can see it. That's all that really matters, right? The location doesn't matter. The accessibility is more important. So that's what this storage virtualization is referring to. Yeah, good question. Frankie, look in the chat. Frankie said, will server admins in the future have to scuba dive to work on servers? I don't know about to working on servers, but I do know, Frankie, if you like scuba, and I had a student that was getting his scuba certification while he was getting his CNET degree. And I mentioned in the server class that there are underground fiber optic cables that go across the transatlantic and transpacific and all over the world. And there are jobs where fiber optic repair technicians will dive down to the bottom of the ocean and to repair those cables. So while you're down there, you might as well upgrade the server at the same time. It's like when your wife says, are you going out in the garage? Can you get this while you're out there? Same thing. Okay, so now let's talk about the types of virtualization. And this is where, again, I'm kind of making fun of the awesome naming conventions, but type 1 and type 2. And a type 1 hypervisor runs directly on the hardware. So with the type 1, it runs on the hardware, whereas type 2 is a program that runs, or an application that runs inside the operating system that runs on top of the hypervisor. So here's a good picture. So type 1, we see this hypervisor here. It runs directly on top of the hardware. So when we I actually did that part for you. When I installed ESXi, I installed it and it runs directly on top of there is no other operating system. The ESXi is the operating system and the hypervisor. So ESXi is actually a Linux kernel, right? It runs Linux, which is called VMware Linux, and it runs directly on top of the hardware. So consider this hardware, this orange bar here, as the server itself. This represents the processor, the hard drive or the storage, the network, the CPU, and any other input output that the hardware may require. And then ESXi runs right on top of that. And then within ESXi, we can build different virtual machines or guest machines. Okay, that's type 1. Hyper-V and ESXi are type 1 hypervisors. Type 2, so let's go back to that assessment that on Kahoot. VMware Workstation is a type 2 hypervisor. So what that means is that we have our hardware. So let's say your home computer, you install Windows on your home computer, and then you download and install the application for VMware Workstation. And then inside of that, you can have your guest machines, right? Your virtual machines. So if you were to just look at these two pictures, and if your guest machine needs to communicate with the CPU, which one is closest to the CPU, a type 1 hypervisor guest or a type 2 hypervisor guest? I mean, physically, which one's closer? Exactly, type 1, because type 1 is, it only has what? One layer to go through to get to the hardware. Whereas in type 2, it has 1, 2 layers to get there. So the more layers you have to go through, the longer the latency or the delay will be. So as far as performance, type 2 is not as robust as a type 1. So that's why our server virtualization is normally always going to be a type 1, whereas our workstation virtualization will be a type 2. Because performance isn't the key thing. If we have VirtualBox running on our home computer and we want to learn about Linux, and that's how we decide to do it, or we want to learn about Android, right? The Android OS, we can install that in a virtual and run that on our workstation virtualization. Speed is not the main thing. It's just, does it work? Whereas on our servers, it's all about speed, right? We're always concerned about performance, and that's why we will have the server doing that. Okay, so those are type 1 and type 2. Now here's a list, and this is just a partial list, but ESXi, Citrix, Hyper-V, Red Hat Enterprise Virtualization, those are type 1, which means they run directly on the hardware. And then Microsoft Client Hyper-V, so the one that comes in, like say Windows 8, Windows 10, Enterprise or Education, those versions include a client Hyper-V. That's a type 2 because it runs on top of Windows. VMware Workstation, Oracle VirtualBox, those are type 2. All right, any questions on type 1 and type 2? Okay, very good. Now just some terms, the VM or the virtual machine can run just about any operating system. Now we're gonna look at in another lecture some of the details on different systems that we'll look at VirtualBox, we'll look at ESXi, we'll look at Hyper-V, we'll look at all these different platforms, and you'll find out that some of these systems are more friendly to more operating system types or versions than others. Now, VMware is not, they don't make their own operating system, right? Whereas Microsoft does, right? Microsoft makes Hyper-V. They also make Windows 10, Windows 8, Server 2012, Server 2000. I mean, all these different operating systems. So the Microsoft would probably be logical for you to assume it's going to work best with its own operating systems, right? It's going to be more friendly to Microsoft operating systems than it may be to, say, Linux or BCD or any of these other operating systems. So whereas VMware does not make an operating system, they work quite well with almost any operating system. So if you can go download an ISO of Android or, anything else, some obscure system, you will be able to probably run it inside of VMware. I mean, it's just more friendly to everything, whereas Microsoft's a little more homogeneous in its friendliness with Windows products only. Now, it does support some Linux versions, but not all of them. So if you have a bunch of different Linux that you want to work with, it may not work real well on that. Okay. So the virtualization software works by emulating a separate hardware environment, and that is managed through the administrative console on the hypervisor. And then our guest operating system, which is also known as a VM, so a VM and a guest are referring to the same thing, is any other operating system. So here's a picture of our host machine is everything. And then we have various peripherals, right? We have a hard drive, we have a keyboard and mouse, the CD. And within this host, we can have different VMs, and we can say we're going to give this one some memory, we're going to give this one some memory, we're going to give this one a hard disk this big, and so forth. And it's all going to work together. Now, how this works is not really the intent of this class. This is not an in-depth virtualization course. It's kind of the concept of virtualization. So this graphic is probably good enough for our understanding. But there are courses that go deep into how does VMware do this, right? And but that's beyond the scope of this course. All right. So with our virtualization, we need some sort of a hypervisor, and then each one of our VMs is going to have two main files. The first one is the configuration file that has all the information about the VM. What's its name? Where's the hard drive located? How much memory does it have? What's the name of the network adapter? How many cores or how many virtual CPUs is it using? That is all contained in the configuration file. And then the other part of it will be the disk file. So a virtual disk file is literally a file on your computer that represents the hard drive. So everything we save in the virtual gets saved in that file. So even though we're saving documents and pictures, all that, it is inside of that VMDK or the VM VHD file on our hard drive. Okay, so the two main files, there's other files that are in there, but the two main ones. So if we were to copy or clone a virtual, we would just need these two files. And really the main one we need is this virtual disk file. That's the big one, because that's the hard drive of the virtual machine. Okay. Now, some of the licensing can get a little blurry in how this works. Technically, when you install an operating system or a virtual machine, or an application on a virtual machine, it needs to be licensed just like it was if it was on physical machines. Now, running multiple copies of the same virtual machine might violate the license agreement for software installed on the virtual system. Now, we're going to run smack dab into this problem when we install in the second half of the class on Hyper-V. We're going to clone using a parent and different child disk, using differencing disk, multiple servers on our system. Now, if we do not run a program on the server before we clone it, known as sysprep, which is system preparation, which removes all that licensing information and all that GUID and the information that the server uses, we'll run into these conflicts where in our domain, it will say, I cannot turn that one on because that machine's already on the domain. You can't attach two machines with the same license on it. So we have to strip that off with the sysprep. So we'll run into this problem. And if you follow the steps, you'll do the sysprep right. If you don't, you'll have to turn off one, sysprep it, turn it back on, turn off the other one, sysprep it, and turn it back on, and then they'll work, they'll play nice together. Okay. Now there are different ways we can virtualize. I'm going to leave some of these slides here for you to look at. So here's some versions of different workstation virtualization, some of the server virtualization, and here's this server sprawl, which means that we're buying servers for every function. And we need power, and we need maintenance, and we need cooling, and we need someone to manage them when we have all these different servers. Whereas with virtualization, we may only have a handful of servers that are running a bunch of virtual servers. And you know, the admin, we still may have specialized admin, but not necessarily. Okay. So here's server sprawl, where we have a web server, marketing server, accounting server, corporate server, and we have 4 servers, 4 network cards, and then they all connect. Whereas we can virtualize it and put it all into one virtualization environment, and away we go. So it's going to simplify things. Okay, here's some of the information on the VMware products and the Microsoft products and so forth. Okay, now with our processors, the CPU on our hardware, it must be aware of virtualization. And in order for that to occur, the processor must be designed with what's known as hardware assisted virtualization, or HAV. And HAV means that the processor is created, right? It's engineered, designed in a way that it can be virtualized. Now, 15 years ago, when virtualization first started, none of the processors were aware of virtualization, right? They didn't know what it was, so they didn't have any specialization for it. Well, as VMware became more and more popular, the 2 main CPU manufacturers, AMD and Intel, started developing code in their processors that allowed them to be virtualized. And for Intel, it's called the VT-X code set. And with AMD, it's just AMD-V. So when you install a virtual environment on a system, whether it's a workstation or a server, one of the things you always want to double check is go into the BIOS or the UEFI settings and make sure virtualization is turned on. And normally it's a checkbox that says enabled or not enabled for the hardware assisted virtualization. If it's not enabled, you can only run 32-bit operating systems. If it is enabled, you can run native 64-bit operating systems, okay? So if you ever are on a system and you install the virtual and hypervisor correctly, but then you go to install a virtual machine and it says, hey, I can't run CentOS 64-bit, that's a good indication that you need to go check the BIOS or the UEFI and make sure that's enabled. Now, some processors do not have this hardware assisted virtualization. Normally your lower end processors like your Celerons and some of the low power ones, I forget the name of the AMD low end ones, but they do not include that because their intent is that, you know, you're not going to buy that really low end workstation and virtualize on it. I mean, they just don't anticipate you to do that. So you have to be aware of that. Okay. Now we can also virtualize applications, and probably the easiest way to virtualize applications now is with software as a service cloud. So we can just, you know, have a development environment and say for programming, and it's all in the cloud, and then it's all virtualized to us. Now, I've mentioned the cloud several times today, and it's important for us as technicians, server technicians, future server admins, to realize the cloud at the foundation, at the building block of the cloud is virtualization. So when you say AWS, Amazon Web Services, I want to click provision a new Ubuntu server, it's actually saying, go create a new VM and then give you access to it. So at the core of cloud computing, at the base of it, is virtualization technology. So remember at the beginning, I said, where our servers are located has changed, but the technology is still relevant. So if we learn virtualization on premise machines, premise servers, the ones we can physically touch and hear and smell and, you know, taste if we wanted to, we can, the concept, the learning will be identical to if we're doing it in the cloud. So the relevance is still there. Okay. Now, with our virtual machines, again, the administrative, this is where we actually configure them. So I'm gonna get to the screen here. So this is that's not the one I wanted, but so shoot, there's a picture that shows the VM client connection, but we'll see it in lab. I'll show you when we do the lab part. But with our virtual machine, we can assign various elements or hardware from our host machine. So we can say, I want it to have this much processor, I want it to have this much memory, I want it to have this much hard drive, I want it to have this network connection, I want to have this USB connectivity, I want to use this part of my CD or my DVD or my Blu-ray, I want to, you know, various things. So we can slice up our hardware, our host machine hardware, and give it to our virtual machine. And that's really the benefit of these virtual machines. Now, most of the time, we are not going to virtualize a system that has a huge bandwidth requirement for audio and video. That does not make sense, because remember we talked about going through layers. How many of you remember getting on YouTube, say 10 years ago, and you'd play a video and it'd run for about 2 seconds, and then you'd see buffering, buffering, buffering. Then it'd play 2 more seconds, buffering, buffering, buffering. So if we have to go through layers, performance is going to be a problem. So some things are not well suited for virtual environments, others are. So if we need to download a file, that's perfectly fine for buffer. If it slows down for a millisecond while we're downloading, no big deal. As long as I get the file in a reasonable amount of time, say 2 minutes or 30 seconds or whatever it is, as long as I get it, I'm happy. But if you're watching a video, or if you're talking to someone over voice over IP, or you're in a video conference like this, and it stops and is super choppy, the experience is not worth it. Okay. So certain things are better for that. Now, just like on our regular workstations, right? Like in CNET 50 and 52 and 54, we learn all about this stuff. One of the key ways that we can improve performance of a machine is to put more memory in it, right? The more RAM, the better the performance. Well, the same thing can be true with our virtual machines, but we have to keep in mind that we only have a limited supply of RAM. We can't go more than what's in the host machine. Unless we add more to the host machine, then we can give it to the virtuals. So there's this kind of cat and mouse game going on there that we have to be aware of. All right. So I'm gonna kind of get to the end of this section on the VM stuff, and here's some information on parenting and cloning. So one of the things that we can do is we can take a user's workstation, we can virtualize it onto a virtual machine. So we can go physical to virtual, and then that user can access their workstation by accessing the virtual machine. So imagine we have an office right now, say during the pandemic, everybody's attempting to work from home, and let's say Ian's machine has some stuff on it, but we don't have enough VPN licenses. We don't have the bandwidth to allow him to access his actual machine. We don't want to leave that running all the time, but our servers are running. We could take his workstation, virtualize it, put it on the host machine, and then give him access using virtual technology to that. And it's as if he's working on his actual computer. So for our remote workers, that's a real problem solver, right? It really made this, some businesses were really able to switch gears and go into this pandemic kind of mode of work and learning overnight, right? It didn't take a lot. And others have really struggled, right? So it just depends. So, but virtualization, it really provides that for that. Okay. And then I'm going to get to where I'm going to start up again after the break. And so these slides I'm skipping, you still want to read through those on your own time. Here's that admin console that I was talking about. So this is what Hyper-V looks like, where we have a host machine, and then we have our virtuals here, and then we can assign it various information. So this is a Hyper-V manager. Okay, I'm going to stop right here, and then we'll take our second break. It's 10 o'clock. Let's come back at 10:05, so another 5-minute break, and then we'll talk briefly. I'm just going to talk a little bit about Windows Server, because the majority of our server applications and settings that we're going to use are on Windows Server 2019. So I want to back end some of these lectures with information about the main server operating system we're going to work with, because we really don't explore that too much up until this class. I mean, Windows 10, by now you know that. CentOS, you've had exposure to that. But server, you really haven't at this point in your CNET career. So this is a good place to do that. So it's 10 o'clock. Let's come back at 10:05, and then we'll keep going. All right? All right, so those 5 minutes go pretty quick, huh? So
Yeah.
I'm just gonna go through a couple of things here, just so you're somewhat familiar with the getting started with Windows Server. So the first thing here is uh, computer networks. It kind of talks about that, and then it talks about where our servers are located. And then most of our servers are rack mount servers with the 1 unit and 2 unit, and the unit refers to the thickness or the depth or the height of the server. 1U is 1.75 inches. So our servers are 1U rack mount servers, 19 inches long or wide and 26 inches long, standard stuff. And then here's a rack mount server. We may have, some sort of keyboard, video, and mouse, a SAN, storage area network, uninterruptible power supply, and then various servers that are doing various things, database, email, firewall. So as you probably know, Windows has been in the server market for probably 25 years now. So they've been around for quite some time, well established, and they allow a lot of services to run on their server. So when we start building our environment and start looking at how are we going to, do our routing, how are we going to do our file storage, how are we going to do our infrastructure services like DHCP, DNS, FTP, those kind of things, web services. What machine are we going to put them on? The answer is we can put them on whatever we want, right? CentOS will do all that, and Windows will do that. Server will do all that. So I want you to be exposed to a little bit of CentOS. This is not a Linux class, but the majority of the operations we're going to do will be designed to run in a Windows environment, because that's what most businesses are going to work with. So here's these last couple of slides had to do with virtualization, which we just talked about. And one of the things that you can do, and the cloud allows this very well, is nested virtualization, which means you can have a virtual inside of a virtual. So I can have a virtual environment, and then you can run a virtual machine or a virtual hypervisor in that virtual environment and have your own virtuals inside of it. That's known as nested. So running other virtual machines within a virtual machine. And Hyper-V allows that. Now with the cloud, typically, like with Microsoft Azure, you have to request nested virtualization. By default, the free tier, the one you get the free time on, they do not have the ability to do nested virtualization. But if you want it, you can request it, and then that's an upcharge. Okay, so here's the nested virtualization here's Hyper-V, and then inside of Hyper-V, we have another machine running Hyper-V with its own VMs. So it's virtuals inside of a virtual. It's like that. What's that movie where the coin spinning, and then you don't know if it stops or not? With Leonardo DiCaprio, it's kind of like that. Is it a dream? Inception. Yeah, thank you, Ian. A dream inside of a dream, or is it actually, happening? So that's my take on nested virtualization. Okay, now Windows is also not just Windows, but a lot of server deployment schemes are using this concept known as containerization. And containers are where we have our operating system, then the software for it, and then we put different systems inside of different containers. And that allows the containers in each separate container to be isolated. So it's kind of like a silo, right? Here's a silo full of, our web apps for this company. Here's another silo or container with the web app for another company. And those apps don't talk to each other, right? We don't want them to talk to each other for security reasons. So this concept of containerization is also, it's a lot similar to virtualization, although it's only really for applications, not for operating systems. Okay. Another thing that we can do is with sandboxing. Now, have any of you used the sandbox feature in Windows 10? I'm watching the chat. I don't see anybody. Okay. I think you need to have a enterprise or a professional version of Windows 10 to do it. But if you just click on Start and then type Sandbox, it will either say Install Sandbox, or if it's already installed, it'll say Windows Sandbox. And what this is literally like the sandbox at the play area, right? When you get there, you can shape the sandbox to whatever you want. And then when you leave, someone else can come in and rake it, and it's back to a clean slate. So with sandboxing, you can take Windows, and Windows will actually install a version of Windows 10 inside of your Windows 10 machine already that you can use as a sandbox. Like, let's say you wanted to test what would happen if I went to this website that I know has a virus on it. And you don't want your main machine to get a virus, but you want to see what that will do. How will it affect the processor? How will it affect my hard drive? How will it affect, right? So do a sandbox, go to a site that has those viruses, and then observe what happens in the sandbox. Worst comes to worst, if that sandbox machine catches fire and burns to the ground, it's in the sandbox. It's not going to hurt anybody. So the sandboxing is a really good way to kind of test out not just malicious, malware and stuff, but any other system. So like if you've had a problem in the past with certain applications not playing well together, you can put them in the sandbox and try to figure it out and come up with a solution so that when you start working in your actual environment, you're not causing any kind of damage. Okay. So that's what sandboxing is. And then there's the containers. Docker is the name of the software that Microsoft uses for containers. And then here's a picture of that. And with our premise machines, with our domains. Now, a domain is a logical continuation of our organizational chart, right? Like if any of you work somewhere where there's an org chart and it says, here's this direct report, here's his people that report to him or her, here are their reports, right? You have the director, then you have, managers, then you have, assistant managers, then you have, line supervisors, then you have, workers, right? So that org chart kind of from a design scheme, you can look at it and say, okay, here's if I need to request vacation, I need to tell this person who will tell this person and tell the, right? So there's those kind of organization. And that's exactly what an Active Directory is, except for instead of dealing with people, it's dealing with everything that consists of our network environment. So that's going to be our domain controllers, our user accounts, our group membership, our servers, all of our security, and all of that is wrapped up in Active Directory. Now, I had a student, this has been probably, 6-7 years ago. He took this class, and after this class, he went for a job interview, and he was interviewing for a PC technician, right? An entry-level position. And during the interview, he mentioned that in his server class, he learned about Active Directory and all this other stuff. And they ended up offering him a job 2 steps above what he was applying for. They said, it sounds like you could do our server admin job, or you could start off as our server technician instead of a network, PC technician. And he came back and he told me, he said, I couldn't have got that job if it wasn't for your, kind of forcing us to learn so much about Active Directory. So, I mean, this is a good skill to get, is this Active Directory. Now, our servers, Active Directory, can be managed either on our premise machines and or on our cloud machines, right, with Microsoft Azure. And they'll work seamlessly together. So we can have part of our Active Directory scheme, or schema is what they call it, on our premise servers, ones we can get to, and we can have other ones in the cloud that, Microsoft is managing them. So that's a great thing. So in Microsoft has been moving more and more and more towards cloud computing. So these skills will transfer directly over there. Okay, security is built into Windows Server, right, with Windows Defender. And this will also protect our virtual machines, hard drives. There's an emphasis on Internet Information Services, web software, which will work with that later on. And then we have our basic security with our file and folder permissions, our security policy, encryption, authentication methods, and others. Okay, so there's a lot of information here about what is in server. So with our server system, this is one thing that we are going to get very familiar with, is this program that's built into Windows Server that's not built into our desktop operating systems like Windows 10. Now, the look and feel of Server 2019 is almost identical to Windows 10. So if you click on Start and you click on, File Explorer and you add software, all of that is like exactly the same way you would do it on a Windows 10 machine. But when it comes to the server side of things, they have this program called Server Manager that will pop up when we first begin. And this is where we go into how do we find or install DHCP? How do we install file and print share? How do we install, the routing and remote access server? How do we install IIS, right? Those things that we need to install on our server will come from Server Manager. So this is a program that pops up when we first start our server. And so when we build our Server 2019 virtual machine, we'll be hit with this right away. So it will give us the ability to manage that server. This is not found on a workstation, because the workstation, normally we just need our applications and we have shortcuts and desktop icons for that. Okay. And then here's the processes running, so we can see our performance information in our server. The features of Windows Server versus the desktop is it's designed to be smaller. It's more, because we're not, generally speaking, we don't turn on our servers, sit at our servers and do work there all day, right? We turn them on, they're in the data center, and they're in another server closet or wherever they're at in the cloud, and then we remote into them. So kind of like this class is designed, where we're going to be remoting into the servers. That's exactly how we would do it in the real world. So they don't have a lot of bells and whistles. You don't find servers with high-end graphics cards or high-end sound cards or speakers or any of that that's there, because that's not their function, right? They're designed to serve applications and services to the user, and we go from there. All right. Now with the cloud, you can read that. Windows Server does support Linux. And I don't know if you have read up on some of the changes they're doing to PowerShell, which we'll have a lecture and lab on PowerShell in this course, but they're really tying in the Linux kernel and the Linux shell with PowerShell, so that the skill set that used to be, here's my Linux skills, here's my Windows skills, they never really met in the middle. Now they're trying to merge those. So there's going to be an overlap between your Linux skills and your Windows skills, and where they will come in is with PowerShell. So the Microsoft Windows subsystem for Linux is more supported on that. Do any of you, during the pandemic or before, did you ever buy a Raspberry Pi? I'll wait for the chat. Well, they have a version of Windows 10 that runs on the Raspberry Pi, and it takes all of the Linux side of things. You manage it with Linux, but it's Windows 10. So what you can do is you can turn on your Pi, and then you can connect to it. It's running Linux, really. And you can, it's like the Windows for the ARM in a lot of ways, Ian, the advanced risk machine. But you can connect to it using, like, say, Visual Studio. So I can create my code and then have it link to my Pi, and then run that code on the Pi, which is run in a form of Linux on it. So it's really interesting. And there's this huge cross pollination or cross contamination that's occurring between Windows and Linux right now. Okay. Here's some information about the various versions of Windows Server. So there's really three main versions: the Essential, the Standard, and then the Data Center. One thing that I want to stress to you, and I'll reinforce this when we get to these labs, is make sure when you install Windows Server, you always install the Data Center edition with the GUI, with the graphical user interface. Otherwise, you end up with a system that is not real usable. Okay. Now with Essentials, it's designed for 25 users. The Standard Edition depends on the client access licenses. Same with the Data Center Edition. The licensing for Essentials is per server, whereas the Standard is per processor core. So the more cores you have, the more licenses you'll need, and the maximum memory. Now look at the maximum memory for Data Center, 64 terabytes. Have any of you ever seen a terabyte chip of memory yet? Yeah, me neither. The biggest I've looked for, and this has been a little while ago, was 16 gigabytes, was about the biggest. Most of them are still 8 gigabytes. And most desktop motherboards are maxed out around 32 gigs of RAM. Not a lot of them go over that. So Louis asked in the chat, is the crossover happening at the command line level, or will it go as far as the software compatibility? It's still just at the command line level right now. The software cannot be compatible between two different processor types. And one of them is the advanced risk machine, or the ARM, like on the Pi, right, with the system on a chip. And then the other one is the Intel, the x86, x64 chip. So they're not going to be compatible. All right. Storage servers, you cannot purchase that directly, but other systems, you can buy network attached storage devices that run a version of Windows Server that will interact and attach directly to your Windows Server. I've seen those that you can purchase that way. Hyper-V, we're going to learn all about Hyper-V down the road. When you're installing a server, you want to kind of have a plan, right? Just like anything. Make sure you aren't using the server beyond what it's designed to do, that it has the proper hardware to do what you want it to do. I mean, if we put a web server on a machine and then it only has 4 gigs of RAM and a 10 megabit network card, we're going to have all kinds of bottleneck issues with people getting good performance out of our web server. So you want to make sure it ties in. Of course, RAID is part of that. Other hard drives, right? We'll talk about disk subsystems quite a bit in this class. Later on, we'll dive into all that. Okay, so there's some more data on this. I'm gonna cruise through some of these, and again, you may need to refer to some of these slides, say during a quiz or during the midterm, but these are searchable PowerPoints. You can, Control F and find everything that you need there. Okay, the installation media, you have to build your own media if we're going to boot from a USB flash drive, which is how most servers are booted. Or if we're doing virtuals, we just need the ISO image file. So in today's lab, we're going to copy some ISO image files over from a network share that I have set up to our workstations. And then from our workstations, we'll be able to transfer it to ESXi. All right, and there's that. All right, so I'm gonna stop right here. I'm gonna let you go through. Some of these are just, what it looks like. I do want to highlight this. Whenever you install server in this class, make sure you're on the bottom one here, which is the data center, Windows Server 2019 data center with the desktop experience, which means it's the GUI. If you do the standard or just the data center, it's not going to have the GUI, and all you're going to have is the server core version, which you'll be like, hey, where do I click here? There is no click in here. It's all, done remotely. All right. So, and we'll always do a custom install, and we'll go over all this stuff when we install it later. And then away we go. Right. So this just walks you through some of that. We'll come back to some of that networking stuff later. And that's it for that. Okay. So with the lecture out of the way now, we're gonna do a couple of different things today in lab. So we're gonna start lab early. Today's lab is not going to be terribly long, and if you go to Canvas, hold on, I'm getting all these emails too. I'm going to share my screen for Canvas. Okay, so if you go to Canvas again, and if we click on modules, under week 1, you will see, hopefully you're able to see it. Let me refresh this. Yeah, there's a page. This is, you tell it's a page because it has a list here for lab 1. Okay. Now I'm going to do something. I'm going to stop the recording because I want the lecture recording and the lab to be separate. So I'm going to stop this.